All right. So what I was explaining, and let's make sure everybody got it, is that week 10 doesn't show up yet in the repository. I tried to upload a very large file into the repository. I think I confused my local GitHub. So now it's like the sync here is running forever. I think what I'll have to do to unconfuse this is to delete my local repository, download the existing repository that's on the site, remake my change, and then upload it. But I can't do that. That'll take me 10 minutes, and so it's not useful to do. I'll do it during the break. Okay, so that won't be there. The data for this class I've put on the U drive. I don't have access to the U drive on this computer, so I can't show you what I mean. But if you go to Windows Explorer on their computer, and this will work on the coast, and it'll work here. You go to the U drive. There's a folder called SPA. Okay, inside SPA, there's a zip file and a folder. That's all that's there right now. Is that right? Is that what you see up here? Okay. So I found that I didn't really have to go to Explorer, but obviously your computer and much of the U drive. Yeah, that's Windows Explorer. Internet Explorer is for searching the internet. Windows Explorer looks at your drives on your computer. So you're actually in Windows Explorer when you're looking at your folders. All right. So if you go to Windows Explorer and you see the file, copy that. Don't use it on the U drive. Okay, copy that onto your local computer. Okay, because there's two problems with using it on the drive. One is that if you make changes and add stuff to it, you'll add more stuff to that file, and they'll get larger and larger. And that's not good, because if somebody else copies it, they'll wonder what that is. Okay, so, and then the second thing is, if we're all accessing it simultaneously, it'll run slower. And then the third reason, I said there were two, but there's actually three. The third reason is that it'll run slow off of the network. So copy that over, and if you go to copy that over, I'm going to do that right now. So this is still failing. Okay, so I gotta do what I said I would do in the middle of class. Okay. All right, I can do this without that though. All right, and you'll have an archive of this because we're doing it in class. Okay. All right, so I'm going to get the data real quick. I already have the data, obviously. Yes. So I put the data under. Actually, I think I moved it instead of copied it, but that's not a problem. I think I also stored it under temp and then risk. I'm going to rename this folder week, what I call week 10 data. So it's consistent with what you all will have. All right, so there's a folder called week 10 data, and inside there's some shape files. There's also some raster files inside of data. In fact, let's open this up in ARC catalog to look at some of the data.
I found two files under spot, the week 10 data and the week 10 data that's zip archive.
Right.
Is that the same thing you talked about?
Yeah, so the week 10 data is the same thing that's in the week 10 data zip, but it's unzipped. So you can copy the week 10 data onto your drive, or you can copy the week 10 data.zip file onto your drive, but then you have to unzip it. So you do one of those two things. All right, so if I go to C, I put it under temp. Wherever you put it, just remember, I put it under temp, and then I called it week 10 data. So these are the data sets that you have. It should look like this in our catalog. Lots of data. There's some extra data sets that you actually don't need, but they're not the big ones. These are the three data sets that you'll use for the second part of the lab, and we'll get to that later. And then these are the data sets that I'll be working with during the lecture and you'll use for the first part of the lab. And if you look at these data sets, you'll see that these are some climate data. This is precipitation. Okay, we've got precipitation 1, 2, 3, 4, all the way up to 12. So this is monthly average precipitation. So here I'm kind of like going through the year. You can see how monthly precipitation changes, throughout the year. Okay, in the United States, if I look at this is February, March, April, May. You can see a lot more precipitation going, in our United States. The Gulf where we are is bright even in February, but the rest of the eastern United States gets pretty bright if we go up 4, 5, 6, 7, 8, 9, and then this is temperature. So we've got maximum temperature throughout the year. By the way, 1 means January, 2 means February, and so on. Okay, and then likewise, here's the minimum temperature. So we've got the average minimum temperature, the average maximum temperature, the average precipitation values. We also have a few other data sets in there. One's just called population. We may or may not use that. And then the last one is called land cover. So land cover is another data set. It's a global data set, and it has the categories of what the various numbers mean. So the numbers each mean a different type of land cover. So for example, here, if we have the land cover data set and we zoom in, this is the natural land cover. I should have called this, oh no, this isn't natural land cover, this is current land cover. All right, so I zoom in here to, this is a global data set, so it's really coarse. But the Mississippi Gulf Coast here, here's Biloxi Bay. And here's, actually this would be, not that it matters, but one of these would be Hattiesburg. So most of the brown area in this image, if I select it, it's saying that that is 4. If I go over to the table again, 4 means tree cover, needle-leafed evergreen. And we know that, if you drive outside the city, that's what you see. Even if you're in the city, you see a bunch of needle-leaf trees, right? Okay. So that's that. I'm just getting you familiar with the data. The point is, the data that I've shown you thus far is not vector data. Okay? Learning the difference between raster and vector data is not within the scope of this course. That's something that you learned back in a 200 level GIS course. But just as a review, raster data is basically like an image. It's got rows and columns of cells, and every cell has a value, and that value represents what? What does the value in general sense represent? Yeah, the attribute in that cell. So the attribute is a good way to say it, because it's very similar to, in the vector data model, an attribute in an attribute table. So if you wanted to have multiple attributes, you'd have multiple rasters. That's one way to handle it. Or something like this, if there's only a few values, like if it's a land cover data set, there can still be a table associated with it, and it can have things like value and a name associated with it. So there's a value, but that value is really tied to a name. And we could have another attribute that that was perhaps even more generalized. Like it may just say tree cover, shrub, crops, bear, or water. Okay, we could collapse some of those and have that as another attribute. So raster, right. Raster data, the point I'm trying to get across here is raster data is always numbers, but sometimes those numbers can represent a classification scheme. Exactly. Exactly what you said. Depends on your classification scheme. All right. So we, in this course, we're learning how to do some programming with raster data, with GIS data. And so we've covered messing with vector data, and now we're gonna talk about interacting with raster data. Okay. The first thing that I wanted to cover is talking about different types of raster data operations. But perhaps we'll cover that along with the ArcGIS portion, so cover them together. We're going to talk about a few different ways to interact with raster data, but today we'll mainly focus on one, and kind of one and a third, because then we'll bring that into next week. We'll talk about the other way. The first way to interact with raster data is to use, and this follows the pattern that we established with the vector data. We can actually just interact with the raster data sets as if we were running tools in the raster, in ESRI's framework. Okay? Remember when we did buffers, we would call arcpy.buffer and buffer underscore management technically. And we would buffer that data set by calling that tool. Well, raster data is very similar, but there's one catch. Okay? When you're using Python, you don't actually run the tool that you think of in Toolbox. When you're using rasters, you formulate the expression as you would formulate it for the raster calculator. Okay? That's how you actually run it. So the trick, just like with some of the earlier labs that we did, the trick here often is only a little bit about Python itself. Okay, there's some gotchas, and we'll go over that. But the trick is actually more to do with formulating the GIS question correctly. Once you can formulate the GIS question right and figure out how would I do this in raster calculator, then it's just simply a matter of doing it in getting that function put together right in Python. Because if you can put the function together right, the same function you would plug into raster calculator, you can do it in Python. All right, and let's first of all, before we even do that, in IDLE, let's do something we haven't done for a long time. And that's open up ArcGIS and do these things right inside the Python window. So if you open up ArcGIS, and I'm gonna close all my windows, except for I'll leave the toolbox open because we'll probably use that. Okay. But I want to show you, in case you forgot. You can open up a Python window right inside, sorry, of ArcGIS. So here's my Python window, and it's opened up right inside of ArcGIS. All right, now all of the raster tools are located inside of this thing called Spatial Analyst. Maybe not everybody here has taken the 418 course. That's okay. We're not going to assume that you have that knowledge. But the tools for doing raster analysis are in Spatial Analyst. So we'll go over some of the tools that are necessary to complete this lab. But if you want a course on doing raster modeling, that's the course, 418, 518. You'll get a lot you get a lot more into doing raster modeling, and you cover a lot more of the tools. But for this course, I'll demonstrate some tools and how they work. But it may be necessary to go look at the help if you don't understand exactly what it's doing. But if you don't understand exactly what it's doing, look at the help, or just say, hey, what's going on there? Why did that need to happen? Okay, we're going to do very simple things, very simple operations. All right. Just like with data access, remember we did data access earlier when we were dealing with vector data, and that's how we got access to the cursors. The spatial analyst tools, the raster calculator, if you will, is available as a separate model. It's in the SA model. Okay, so arcpy.sa contains all of the functions that are available in Spatial Analyst. So for example, arcpy.sa plus, that's a tool in ArcGIS. What do you think plus does? I mean, just even if you haven't taken 518, 418, what does it sound like it does? Pluses. I heard adds is a better answer. Okay, it adds 2 data sets. So I can do that real quick. Watch. If I go import ArcPy, which I don't think I actually have to do when I'm in ArcGIS, but I'll type it in just in case. Yes. So you should do that. If you go into geoprocessing, sorry, not geoprocessing, customize extensions. If your spatial analyst isn't turned on, you need to do that. Most of these machines it'll be turned on, but because we've had to log in now differently, this only work. I mean, this may not be checked if you've never done it before at this computer. So go under extensions, customize extensions, and turn the spatial analyst extension on. That's a very good point. We're actually, when we start running this code from the Python window, we're going to actually have to execute code that does that, because yeah, still has to check out the extension, still has to license it. So it's kind of a bummer, but the spatial analyst extension is another, $5K on top of the license for ArcGIS. In fact, the spatial analyst extension is the most expensive extension that ESRI sells. There's other third-party extensions out there that probably cost more, but that ESRI sells as an extension pack, it's the most expensive one. It's probably the most popular because it's very useful. It's a very useful extension. By the way, this is a little bit of a sidetrack, but last week the question is, why should we? What's the purpose of doing this in using GDAL or Ogre rather than using ArcGIS? The reason why this just came to my brain right now is because I said, well, one reason is it's cheaper, right? And I thought that was the primary reason, and I still think in a lot of ways it is the primary reason, because money motivates a lot of things. But I didn't bring it in, but I was curious. I wrote a small program that created 25,000 polygons right next to each other and just shoved them into a file. And I wrote the exact same program using the exact same code to generate the polygons in Python, but in one program I made it input using GDAL. Another program I made it input the polygons using ArcPy, and I was actually thinking that ArcPy would be faster, but I was going to see how close they were. Well, to my surprise, the ArcPy version took 4 times as long. So it took about a second for GDAL to do it. It took about 4 seconds for ArcPy to do the exact same thing. And I played around with a few different ways to do it. Like one way was I generated all of the polygons first, and then I tried to shove them into the file instead of writing them each time through the loop. That didn't seem to affect it. In fact, it seemed to make it worse in both cases. So it's actually better to write it during the loop, except for very small data sets. Okay, once data sets got anywhere over 100 or 200 records, it was faster to write it inside the loop. And then second thing I did was I tried making the data set really, really large. And still the same thing happened. It was almost always 3 to 4 times as long that it took in ArcPy, which is interesting. You're paying for something, you expect it to perform better, but in this case it wasn't the case. I will admit the ArcPy code was maybe 3 or 4 lines of code less, and we're talking about a 20-line program, so that's a little bit of a difference, but that's really not much of a difference, especially for the performance hit. The other thing is that ArcPy allows you to input and output lots more different types of data, like file geodatabases. You can't write file geodatabases in GDAL. So, but a lot of the other ones you can. Anyway, a little bit of a side note. So back to this. We're going to use the SA module, and we've gone ahead and checked the extension, so we don't have to check it out we don't have to check it out in code yet, but we'll cover that. And if we want to run SA commands, we just type in arcpy.sa. And then the name of the command. Notice that when we're actually in ArcGIS, the data, all of the commands that are available are actually there. Okay, so like I mentioned plus before, and if I hit a parenthesis, off to the right, it'll tell me what the inputs are that I need to use to get those. So it looks like I need the input raster and the output raster. Or sorry, not the input. 2 input rasters. I'm adding 2 different data sets together. I need 2 different data sets. So let's add January precipitation and February precipitation. So I copy that and I paste it. It needs to be in quotes because it's a string. And I'm going to put R in front of it because the slashes will cause a problem. And then I'm going to just paste the same thing again, but I'll just replace the 2 with a 1. And you're going to have to change your path. I'm sorry, what? You could, yep. You could add it to your table of contents, but we're going to be writing scripts in IDLE, so you're right. If you added it to the table of contents, it would actually show up there in the help. I'll show you what James is referring to. So if I went to see temp, and then what is it? Week 10 data, and I added some of this data, like let's say these 4 data sets. I add them. Now, instead of saying this, I could just type space, and it prompts me with the data sets I have loaded, and I could actually just say precip 1. Okay. So this will work just like my other command. All right. So now I'm going to hit enter. And it's going to think for a little while. It's adding those 2 fairly large data sets together. And it's showing me where on disk it put that. Now, if you're running this as a script, it won't actually show where it put it. Okay? It won't put that anywhere. and that can be a problem. Okay, so the way to get around that is to actually assign it a variable. So I could do this and say x, or I'll just say out ras equals. Now I'm saying the output raster is equal to this. And now it's going to actually be saved to that location. So this works almost exactly like raster calculator, where raster calculator is a function that returns a value. So this is the function, and it's returning a value, and that's the output raster right there. Okay. So now if I hit this again, it'll take a few seconds. It's doing math, and this time it won't tell me where I put it. But if I say print out ras, it will report to me the location that it put it, okay, where it put it on disk. So out ras was my output raster. So if I wanted to add that data set or find that data set, I could take this string and find it on disk by pasting it back into ArcGIS. This is just asking me if I want to build pyramids. Okay, you may or may not be familiar with what that means. Basically, pyramids are intermediate rasters. So basically, it's calculating what that raster needs to look like at a bunch of different zoom levels, so that it's easier to zoom and pan around. You can hit yes or no; it doesn't really matter. But there's my output. It doesn't really look like anything special. It's just January and February's temperatures added together, but it worked. And you can see here that the numbers are pretty high. Or January and February's precipitation. Which one do we do? Precipitation. So it's January and February's precipitation added together. You can see 91. In fact, there it is right there. It actually added it by default. It added it. So if I turn on everything, okay, that's fine. Now it's telling me that I'm clicking off of it in our catalog because it's telling me that it can't get an exclusive schema lock. All right, so I turn off everything. I only have outras, precipitation 1 and precipitation 2 checked. I'm going to do identify and click on a point. Oh, I'm going to change this to visible layers and click on any point. Okay. And you'll notice I clicked on that point, and the value of precipitation 1 was 93, and the value of precipitation 2 was 100. 100 plus 93 is in fact 103, right? That doesn't take a lot of math brains to do, so I think I'm safe. Okay. One more just for fun. No, that's not very fun because it's hard to do. But 325 plus 324 would be really easy because it would be 1 minus 650, which it looks like it worked. Okay, so that one's a little bit more fun to add. Okay, we've got it. We ran it. It worked. Okay. You can chain together as many functions that ArcGIS does as your heart desires. Well, I mean, the computer only has so much processing power, but theoretically, that's the limitation. Okay, ArcGIS doesn't care if you strung together a big old raster calculator expression that was humongous. Okay, that was really, 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 really big. It theoretically doesn't care as long as you have time to sit around and wait for the result to happen. Okay. All right. So that's how it works. Now, a few things to think about. Okay. First, every time we run one of these, we have to type in arcpy.sa. Okay? That's not really desirable. It'd be nicer if we could just type in the function name plus, because then it would look almost exactly the way it looks in Raster Calculator. Okay? And all the help is actually written like that. So what you can do to do that is say import, from ArcPy import star. So another way to say that is from the arcpy.sa module, which on disk is really just a Python file. And inside that Python file, there are a number of functions that are defined in there. All of the functions that you'd want, or all the functions that are available in ArcGIS. So plus is defined in there. Zonal statistics is defined in there. Con is defined in there. All of those functions that you may or may not be familiar with are available inside of this module. And if you say arcpy.sa.import star, then you have access to all of them. The problem now is that when you type in arcpy.sa, that's really the only way to see them. Okay, so you have to know what they are, or you could just start typing. Like if you think it's called add, you could start typing add. And that didn't work. Does plus work? Yeah, plus is there. Okay. You could get a number of different functions. So another function is that we could actually use. Let's say cell statistics. That's another function. So as an example, you can actually use this. You could use this in your lab today. Okay, cell statistics. Let's see what that does. Okay, cell statistics is asking for a list of rasters and then a statistics type. Oh, by the way, the squiggly brackets mean optional, and the and with no squiggly brackets, it's not optional. So the list of rasters is optional. I mean, is not optional. So let's give it a list. Well, we could go precip. Yeah, we need the quote. Precip 1, comma, precip. Oh, we need the quotes. Precip 2. Let's leave it at that for a second. And then say comma, and it's going to ask for the statistic we want. And we could say sum. And what we're doing there is saying, all of the rasters in this list, we want this statistic. So we could get the mean, the average value. We could get the median, I think was one of the options. Maybe it wasn't. Let me look again. Median was one of the values. We could get the range. I'm going to do sum here just so that we can test to see if it's actually working. All right. And again, I'm going to assign this a value. I'll assign it out ras 2 is equal to cell statistics. So really this is doing the same thing as the plus in a new way. I think the sun is going behind Paul B. Johnson. Whew. Feels much better. Okay. Hopefully it's not just a cloud and it moves out in a few seconds. All right. Notice that once I ran it, my output raster 2 and my output raster had the exact same high and low values. That's a good sign. And if I click on them, 97, 97, 0, 0, 368, 368. So it did it. It did the exact same thing I wanted. I was able to add those up using a different function, a cell statistics function. Finally, I'm going to do it one more way. ArcGIS actually allows you to input any valid raster calculator expression. And so we know that you could actually just put a plus sign in between these two data sets and it would work, right? So as a raster option, we could say out raster 3 is equal to, quote, precip underscore 1 plus pre underscore 2. All right. Now, you might be wondering, well, George, that file, I mean, that expression, what does it normally evaluate to? If I said if I put this into a Python interpreter right now, what would outRAS be? Look at that. It would concatenate. Okay, for those who don't remember what that fancy concatenate word means, what does that mean? Concatenate. It would combine them, exactly. So it would take PREC_1 and it would combine it with PRC_2, and if I print that value, I'm going to get that. See that? That's just those two shoved together. Okay. Unfortunately, the same thing will happen in here. Okay, print. Notice how, did it take a long time? No, it didn't. outRAS3 is just those two pushed together. Okay. All right. In order to get this expression to work, you have to tell ArcGIS, or sorry, you have to tell Python, that these are raster data types. Because Python knows that if I put a plus sign in between two strings, concatenation occurs. If I put a plus sign in front of two numbers, what occurs? Addition, exactly. If I put a plus sign in front of two rasters, if I'm using Python by default, it'll say, what the heck are rasters? But if I've imported ArcPy, it knows to take those two rasters and add them as if they were in raster calculator. So all we have to do here is say raster. It's like converting a data type. Okay, remember the conversion, to convert something from an integer to a string, we type in int. So we're converting that string into a raster. And now if we run this, see, it takes a few seconds because it's actually doing a large calculation, a fairly large calculation inside of its brain. And we get our output raster value, and if I click anywhere, again, 3, 2, 1, they're all the same value. All right, so that's one of the, I don't know if gotcha is the right word for it, but that's one of the things that you need to think about when you, whenever, that didn't go behind a building. Whenever you're doing ArcGIS, SA, spatial analysis type operations, is that you need to convert strings into valid raster data sets before you utilize them in expressions where it's not obvious to Python that they are not strings. Okay, so in this example, okay, when we were using it in the cell statistics function, it understood, oh, okay, that's giving me a list of strings, but cell statistics isn't a function that I normally have to deal with, so it knows to convert those. This is a valid Python function, and so it needs you to convert those rasters initially. Okay, it never hurts to convert them to rasters. So if I put raster parenthesis right here inside this thing, it wouldn't do anything different. It would still work. Okay. In fact, it's actually doing that in the background, but it never hurts. Okay. The other thing is that when you're running this in Python itself, not the other thing, the next thing I want to talk about is that when you're running this in Python itself, there's no way to predict or to know where it saved it, and in some cases, it may actually, it determines that if it's small enough, it actually saves it to the computer's memory. It never even saves it onto disk. So if I executed this expression right here, it wouldn't be on disk. And if I wanted to look at it, I would have to tell it explicitly, save this to disk. I have to tell Python to save that file out to disk. So that's what I mean by, go back to this for a second, this save function. So I'm jumping around a little bit here, but I covered the raster function. Now this save function here, will allow me to save this file. So I can just type in any raster, outrast3 dot save, and I can give a path. Yes. Okay. That is a great question. That's actually something that I was going to address. So that's up here. So I'm going up this list. The very next thing I was going to talk about here was the cell size and the extent. Okay, you got to watch out for those. Okay. All right. So just to demonstrate this, I'm going to save this as precipitation added. So see, I've saved it under R, C colon. And if I press enter, it'll actually save this out onto disk. It's saving it to that location, and I can see it. I don't know why I went back to, oh yeah, I know why. Where's the back button? I don't see it. Way too much stuff. Data, there it is. Worldwide data, refresh. And now I've got precipitation added. So I've saved that onto disk. So that is the raster function, the save function. And now to address James's question, what if the cell sizes are different? And actually, another question is, what if the extents are different? Okay? Those are things you need to watch out for when you're doing raster. And actually, something I didn't put on there, which maybe I should have. Maybe I'll do that here real quick. So what if cell size or extent, I'm also going to say also watch out for no data. Okay, we had that problem with earlier with our vector data even. Okay. No data is kind of like a meanie. Okay, it smashes out any operation on no data turns into no data by default. So if you if you add something to no data, you get no data. If you divide something by no data, you get no data. So it's best to convert things. So we'll talk about that in a second. Let's first address James's question there. Cell size. By default, ArcGIS, and not all GIS software is like this, but by default, ArcGIS will handle cell sizes of different values. But by default, it will convert your output data set to the largest cell size of any of the inputs. Okay? So if you don't want that to happen, you have to change it. Okay? And there's a setting to change it. So if I go back to ArcPy here, and I type in arcpy.env.cell size, I can change the cell size. I can change it to whatever I want it to be. Notice here that the current value is max of. I told you that's the default. The maximum of the inputs. You have to go look in the help, and we can do that real quick to see what the other options are. But it is possible to just put a real number. So if you put 5, your cell size will be 5. You put 10, it'll be 10, and so on. So if you want to tie it down to something, you can. arcpy.env.cell size. And let's see if this gives us any. This is an older version. Be nice to have this in at least 10.1, because 10.1 is what you all have up here. That's not working. Maybe I'll just type in size, cell size, 10.1, just to get the 10.1 help. Oh, it was right underneath, sorry. All right, so I've got my 10.1 help. I don't know why it didn't show up on the right page, 10.1, and then raster analysis, cell size. All right. So these are the options. I can say max of, I can say min of, or I can feed it a number. But often what's really nice is I can actually give it the name of an existing data set. So in other words, if you want to match the cell size of an existing data set, just feed that in there, okay? So that would allow you to match an existing data layer. For example, if I just said cell size equals and I gave it pre-sip_1, I put it in quotes, and I press enter. Now if I say print arcpy.env.cell size, says max of. Shouldn't say that. Let's see if I do 5, what's going to happen? I don't know why it didn't accept that. I'm not sure why it's not accepting the that. Okay, you can still use the cell size the way I described it. Here they've got, maybe it needs the full path. Let's just try that. So there's the full path. That worked. Okay, so although it said layer name, it did not actually accept the name of a layer in ArcMap at the time. It needed the full path to that file. Okay, so if you were running this from ArcGIS, or sorry, from Python, you'd always have that anyway. You wouldn't have the name of these values. You wouldn't have these guys. So if we were running this from IDLE, which we'll move over to IDLE here in a second, you would have to give it the full name because PREC_2 doesn't mean anything to IDLE. All right, so that's how you can set the cell size. The other thing that I said is even a bigger gotcha, a bigger watch out, is that the extent is the same. By default, if I say print arcpy.env.extent, I spelled it right. Oops. By default, extent, I guess it doesn't equal anything. Usually, it actually equals the minimum of. I'm pretty sure that if it actually ran through, it would use min of. That would be bad, especially if you've got one data set that's really, really small and one data set that's large, and you want to add those two data sets together. Your output's only going to be in the smaller, the intersection of the two. So let's look back at the help for a second. And if we go to, I think it's processing extent, output extent. So these are the different options that we can give it. We can give it a extent object. We can create an extent object. That's probably something that you could do, but it's probably the more complicated of them. But you could give it something like that, an extent object, or you could give it the minimum of, the maximum of, which I think the minimum of is the default. The maximum of is the if you intersected both of the bounding boxes, it would be a box that could surround both of the input bounding boxes. Okay? And you can just give it a space delimited xmin, ymin, xmax, ymax, or finally you can give it a path name. A path name meaning that a file. Okay? You have to give it the full path. I'm pretty sure. I don't know why you wouldn't. All right, so those are our two gotchas. Okay, one more thing before we switch over to doing this in IDLE. Remember what I said about the problem with no data. No data will always produce no data. And if you want to treat no data like 0, which is oftentimes what you want to do, okay, if you're adding, 5 different data sets together, and you want to make sure that cells that are within, cells at the same location are added together, then you need to convert those no data sets to 0. First of all, maybe I should back up just a little bit and talk about, because this isn't 518, 418, talk about what's happening in the functions that we've used so far. All of these functions have added 2 different data sets together, okay? And it may be that you're not familiar with exactly what's going on if you haven't taken 418, 518. But really simply, let me explain this by looking at the tool, the math plus tool, and looking at the tool help. This will help us to get that. All right. So what's occurring is I'm taking 2 different raster data sets. Raster data set 1, in my case, this was precipitation 1, and raster data set 2, which was precipitation 2, and I'm adding them together. What happens is that I'm just going through every single cell, and I'm taking the corresponding value of that cell in grid 1, and I'm adding it to grid 2. So 1 plus 0 equals 1. Then I can move to the next cell. 1 plus 1 equals 2, and so on. Okay. You may be asking, why the heck would I want to do that? Well, there's lots of reasons, actually. It may be that these represent precipitation values for each month. Not may. These actually do represent precipitation values for each month. And if I wanted to ask the question, what is the total amount of precipitation for winter, I would add together, at least in North America, I'd add together precipitation 1, precipitation 2, and precipitation 3 values, and my output would be the total winter precipitation. So that's just one application. Okay? Again, 418, 518 course is where we talk about all the different, we call this concept map algebra. And it's really an exciting thing, but that 418, 518 class is really where we cover tons of different applications for that you can do once you start adding things together. This type of operation where we take one cell at a time and we either add, subtract, multiply, or divide another value is called a local operation. If you think about it, it's really the same type of thing that you're doing, because back to what Hilton said, we can think about these as attributes. So it's really the same thing as calculating, creating a new field, and doing a field calculation on that that new row, new column. Okay, so these are attributes, and we're adding them together, subtracting them, multiply, dividing. There's all sorts of things we can do. Anything that you can do in raster in calculate values, you could do in raster calculator. All right. So that's enough on the adding them together. And what I wanted to do is show you the function that you would use to convert no data into 0, because that's actually something that you need to do a lot. All right. So here is my output grid. I'll call it out. I'll call this out grid, and I'm going to say equals. There's a function called is null. Capital. Is null is a function. I don't know why it's not showing me the inputs. The only real input, there's only one input. I don't know why it's not telling me what it is. But the input is the data set that you want to find out. And so if I choose output raster, if I choose precipitation 1, what this is doing is saying if the value in every, it's going to check every single grid cell, and it says if that value in the grid cell is null, tell me that it is null. Give me a true value. Okay, remember when we covered in Python a long time ago, a true value is any non-zero value. Okay, so it doesn't actually return any non-zero value. It always returns 1. Okay, so if this statement evaluates, this is null statement evaluates to true, it's going to return 1. If it evaluates to false, 0, it's going to return a 0. Okay, it's going to return a true or false. So I'm going to run this really quick. Maybe that's why it didn't work. I thought is null. Capital is null? It's capital, sorry. It's capital I. I press enter, it runs through, and you'll see that what it did was it created this output raster where everywhere it was null, it assigned the value 1, and everywhere where it was not null, it assigned the value 0. See that? 1 out here in the ocean, 0 on land. All right. Now, that's actually not quite what we wanted. So I told you, I'm going to tell you the function to convert no data values to 0. So far, I've converted no data values to 1, and I've converted data values to 0. That's not really what we want. Okay. So there's another important function that everybody should learn how to use, regardless of whether or not you took, 418, 518, and that's the con function, C-O-N, con, the con function. So I'm going to take this out grid 2 and say it's equal to the con function, and here I give it a raster where it's going to evaluate, and if it finds a false value, I'm going to be able to give it what I want to be false. And if it finds a true value, I can tell it what I want to be true. So if you're not following me after I type this in, then now would be a good time to ask a question. Is null, and I'm going to feed it the precip1, prec1, okay? That's going to create this grid up here that's going to be full of 1s and 0s. 1s out here, 0s here, okay? Notice here in the help, it's telling me that my next parameter is the value that I want to have happen if true occurs. True is what, in this case, I'm going to get 1s and 0s as my output. The output to this right here is going to be either 1 or 0. Okay? So what does true mean in this case? 1. What does 1 mean in this case? What's the output here? What does a 1 mean in this raster? Null. Yes, that it was null. And so I said that I wanted to assign 0s to all null values. So I just type 0, and it will put zeros in place of everywhere where it is null. If not, the false value needs to be the original input value, which in our case is going to be the, what's that? The precipitation 1, okay? All right. So let's read this statement now that we know a little bit more about what it means. It's a conditional statement. And what we're saying is, if the value, the is null thing is saying, if the value is null, then assign a value of true. If the value is not null, assign a value of false. The conditional statement is then saying, if this part evaluates to true, if that part evaluates to true, assign it this value, which is 0. If this part evaluates to false, assign this value, which is the original value. So in other words, a quick way to say this is, if the value is null, make it 0. If it's not null, make it the same as the input value. So I can just read it down the line. The conditional statement is an if just like an if-then statement that we learned about at this point. So conditional statement, you read it, if, and then I go inside there. If it is null, give it a 0. If not, give it the input value. So now I'll hit enter here, and we'll see if it works. Okay, and it does work. So we've got our values out here in the ocean now. I'm going to say topmost layer now. Our values out here in the ocean equals 0, and our values inside still are the same as they were. It left those values alone. So that's something that's actually a function that you have to use a lot when you start dealing with rasters, converting no data to 0, and vice versa. The opposite is set null. So set null will set values to be null if they match an equation. So if we wanted to reverse this process, we could say set null and then use the output grid and say equals in, I forgot whether it's equals or equals. We'll try equals. In Python, it would be equals, but I mean, Python would be equal. But this is inside of an expression. So one way to check this is to just see what we would do. We'll just try it both ways. And if it fails, then we'll do it a different way. Okay, outgrid equals 0. And then we would say set the values. Yeah. This is going to set anything equal to 0 to null. Okay, let's see if this works. I'm just going to call this, P1, just for quick. Okay. Equals. Set null takes 2 arguments. Okay. You have to put the false value. So you have to tell it, oh, I want the values to be equal to. In other words, what this is saying is, if the value equals 0, set it to be null. Otherwise, leave it alone, which is what you're doing there. All right, so I hit enter, and it processes, and P1 should take me back to the original data set. And if I turn these off, I could probably see that. What's that value out there? 0. Okay, that didn't work for some reason. Because that's still saying that those are 0, not no data. Try with just an equal sign. Nope. Okay. One more try. I don't know if this will work, but Still didn't do anything. All right, that one is not as critical. We just need to work it out and get the syntax. I wasn't even thinking of demonstrating that, but set null should allow us to do the opposite. For some reason, well, you know what? One more try. My guess is that we don't even need to say equals, because if it's 0, it's going to evaluate to be false. So let's see if this works. Nope, that just set everything as null. Wait, is that the only one on? There's got to be some other one on. There we go. So the value there is no data. So it's actually looks like it's the opposite of what I said. So maybe if we went as not equals up, does not equal 0. No, Python is this way, right? Yeah. All right. Yeah. So I have to go read the syntax. I'm floundering a little bit there on an example that I wasn't going to show anyway. All right. So let me scroll back up to show you the one that is important. This expression right here will take a data set, and you would need to feed it, whatever data set you're looking at, it'll take a data set and convert no data values to 0, so that you can add them, subtract them, multiply them, divide them by whatever you're working in. All right. So we've covered the raster function, the save function. We've covered this watch out. We've covered, oh, I said set null. I actually wanted to show is null. I should say is null assigns no data value to an area, like I said. Any arithmetic operations will work. Like I showed you before, you use the plus sign, divide, multiply. Multiply is the same in Python. You use the asterisk. The issue is that you do need to convert them to rasters for them to work. And then the con statement. The con statement is the statement that you should read about a little bit more. It just does a conditional statement. Okay. All right, we cover everything that we've talked about up to this point is what we refer to as a local operation. Okay. Refer to them as local operations, and we're not going to spend a bunch of time talking about these, but there's other types of raster operations. Neighborhood operations go through a raster grid cell and examine the neighbors. One of the most common neighborhood operations is to find the slope. The slope will tell us how quickly the values around it are changing. Okay? Another common one is to just find the average value to smooth out a raster data set. Those examples of neighborhood functions. And then finally, zonal operations, which we probably will get to a little bit when we talk next week. A zonal operation, what it does is it's for finding out the total values, or the sum of the values would be another word for total, by a particular zone. Let's say that you were looking at a bunch of cities and you wanted to find out what the average temperature was in a bunch of cities. You could use a zonal operation for that. Okay. And before we switch over to ArcPy, actually, let's do that. We're not going to do cities because I don't have the city data, but I do have this current land cover data set. Okay. So I might be interested in finding out what the average July precipitation is in all these different land covers. That's actually a question that the scientists might really ask. How much precipitation is occurring in different land covers, and is there a significant difference between the precipitation that's occurring at different times? Well, I can do that in Python here by saying it's a zonal operation. So there's a number of different tools for that, but we're going to use, we'll call this out stats, and say equals to zonal statistics as table. It's going to produce a table. I'll demonstrate both this one and the one above it. So zonal statistics as table. Zonal statistics as table. And then look at the inputs here. It's asking for the zone data. It's asking for the zone field. There's a bunch of information that's asking for. With some of these more complex operations, it's asking for lots of things. It's kind of hard to read it in here. I don't like it. I'm going to open this up inside the help and get a little bit more information about it. Zonal statistics as table. All right, tool help. Put this off to the side. I'm going to close. How do I close this window? At least I can make it smaller, right? All right. Okay. So here is the syntax, basically the map algebra syntax right there. So I need the input zone data. The zone data is either the polygons or the polygon-like raster. In our case, it's the land cover raster. So you can't put a continuous raster like elevation in for the zone data because there's so many different values. Zones have to be like areas. Okay. Here's a better diagram up here. So this is our zone data. We have 4 zones in this. We have zone 1, zone 0, zone 4, and zone 2. And what we're going to do is find out the raster value in each zone. So if I wanted to find, let's say I'm interested in, this represents precipitation, and I want to find the total precipitation in zone 2, I just add 1 and 2 and 2, and what do I get? What's 1 plus 2 plus 2? 5. So if I look at the value 2, and I look at the sum, I get the value 5. Okay. Likewise with zone 4, I get no data plus 3. So I get 3 because no data always evaluates to nothingness. So with 4, I go over, the sum is 3. Okay. All right. So that's what we want to do for our data set. So we're going to do this in Python. We say outstats equals zonal statistics as table. First thing we want to do is feed it the zone data, which is the current land cover. So we say quote current land cover. Then we want to feed it the field that represents the zones. In our case, we could probably use the class names or the simple class names of the value. Probably use any one of these. Let's see. Yeah, the simple classes is over there. Okay, I already had that. Okay, let's use the value. Well, actually, let's use class names and see what happens. I'm not sure what'll happen, but class names. It's going to give us the. We're looking for the total precipitation. Actually, let's not use total, because if we use total, it's going to depend on how big they are. We're looking for the average precipitation in each of these classes. All right. Next, I need the input value raster. The value raster is the raster that I'm trying to get the total for. Okay. The raster I'm trying to get the total for. And in this case, it's the precipitation data set. I'll just do precip. I know I said July, but we don't have that one loaded. So I'll just do the average February temperature. Okay. And then next, I need an output table. In this case, it is actually going to save it in a location on disk. So I need to specify that location on disk. So here I would type in something like C colon, I'd put an R in front of it, C colon slash temp slash test dot, I'm gonna call it precip dot dbf. dbf is a valid extension for a table. If you don't put the .dbf, it'll save it as an info table, which is messier to deal with. And notice all the rest of the stuff is optional. Okay? Ignore no data is the next one. I believe that I do want to ignore no data, but let's see if that's the default. Let's see, what does it say? Determines whether no data values in the will be influence the results if they fall within any, if it says data, it's going to only cells that have a value in the input value raster will be used in determining the output value for that zone. No data says in the value raster will be ignored. That's what we want. Okay. Data within any particular zone, if any no data values exist in the value raster, it's deemed that it's insufficient information to perform. We don't want that to happen. I'm pretty sure that data is the default, but we could type in data just to make sure. That'll make it force it to still. A simple way to say what it's doing is if you put no data in there, if there are any no data cells in that zone gets the value no data. And that's not what we want. Okay? We just want to ignore no data, pretend it doesn't exist. All right. So I'm going to hit enter here. And it's going to take a few minutes to run, maybe seconds or minutes. It's going to take a little while. It's doing this on a very large data set. It's finding the average values. And here is the output. Open up the output there. So now I have a data set, and I can see by each class what the average rainfall is in that data, in that one. Let's sort it by that value. Okay, so let's look at the first one. Bare areas have the lowest average rainfall. Make this smaller. Okay. Tree cover needle leaf deciduous have the second lowest. Okay. In other words, the area is exclusively filled with trees that are needle leaf that still drop in the winter. I don't know exactly what that would mean. Tree cover burnt has the next littlest amount of precipitation. Sparse herbaceous or sparse cover. We go up even more, we get to shrub. Finally, we start getting into tree cover types. Okay, so in tree cover types, we have even more precipitation. Regularly flooded tree areas, trees and shrubs, even more. Okay. Snow and ice, we have a lot of precipitation. Cultivated and managed areas happen in precipitation areas. Now let's go up to the very top. No data. That doesn't really. But tree cover, regularly flooded, freshwater, those areas have the most average precipitation, which kind of makes sense. So, we're talking about like areas in South Louisiana that they're trees, but they're mostly flooded underneath for most of the year, regularly flooded underneath. Those have the most precipitation in them. Also, mangroves would fall into this category. Okay. All right. So that makes sense. So we've demonstrated a zonal statistics operation. All right. So let's see. I think we've demonstrated most of what we want to talk about, except for this. Okay. I'm going to demonstrate this right now and kind of leave it at that for next week. So then we'll take our 10-minute break. I'll try to fix this so that this actually pushes up onto the internet. and then we'll get into what you need to do for the lab assignment. All right, so we're going to leave ArcGIS now. So I'm just going to leave this open. Well, it's going to probably going to cause problems if I leave it open. Maybe I'll save it in case I want to come back to it. I'll save it here in the directory I've been working in, which is C temp week 10 data, and I'm just going to call this okay, so I saved it, close it up. Now I'm going to open up IDLE, and we're going to be working from IDLE for most of the lab time. And I'm going to create a new window, and I'm going to create a script. I'm going to say import ArcPy, and I'm also going to say import or from ArcPy import star, or sorry, ArcPy.sa. And this will allow me to run SA commands just like I did before. Where I don't have to, every time I run a command, I don't say ArcPy.sa. I just give the command. So instead of saying ArcPy.sa plus, I can just say ArcPy.sa, and it works. All right. Now, like somebody was saying, we've got to check out that extension. Let me type in ArcPy.sa. This, rather than mess up on the spelling or something, I'm just going to cut and paste this from the text. Where is the checkout? There it is. So you have to do this, especially if you're not working in ArcGIS. Every time it runs, you got to do this. And if you want, it's always best practice to check it back in. Now, as soon as the script, as soon as you close Python, it will check it back in. But I'm not sure where the help is on that. So I'll find that in a second. But we've checked out our extension, and you have to do that, otherwise it won't work to run ArcPy commands. Okay, you have to basically check and see if there's an extension available. We actually have pretty close to unlimited. We can license up to 6,000 machines to run ArcGIS. Now on our servers, we've only licensed them for 100. So if we ever get a class that has 100 people in there and they all press run at the same time, it would return a message that said, "Hey, you can't do that." But we're not going to get there. So we can say, check out that extension. Now let's just do the same thing we did in terms of the plus here in this one. So we did outras something like this equals plus, and then we just fed it two different data sets. I'm gonna get the right. That's exactly what I'm trying to say. Is you don't have to say SA dot plus. Why? Why don't you have to say SA? Right. We imported as star, and that's why we don't have to do it. So this says import every single function from that module so I can refer to it. You just have to be careful when you do that, because if you imported another module that also had the name plus, there's no guarantee that plus would map to the correct function. So it would probably just depend on which one imported second or last, is what I should say. So somebody else wrote another Python module that you imported, and it had a function named plus, there would be a conflict. Okay, so that's the only reason that you have to worry about that particular issue. All right. So now I'm just going to print out RAS and try to run this. And I'm going to save this as my first example here. C courses, SPA week 10. And I'm going to call this example 1.py and run it. And it's going to hopefully tell me where it is on disk if it saved it on disk. It's taken a little bit longer than I expected it to take. Okay, good. So yeah, it told me where it put it on disk, which is good. Sometimes if it's a smaller raster data set, it'll save it in memory, but it didn't save it in memory. And so it saved it on disk. But let's say I want it in a different location. All I have to do now is say outras.save and save it into that different location. So here I could save it to a different location, which would be, I'll call this precipitation add, and run that again. So now it's going to save it. I'm just redoing what we already did in IDLE. So it did it, and now I should be able to see it in that data set. Refresh, precipitation add is right there, and it did it. Okay, so this is doing it in IDLE versus doing it regular. Okay. All right, another thing that I want to show you is, and the way I'm going to show it to you may or may not be the best way to do it anyway. Okay. Right. In fact, I'll show you two different ways to do something. What if I wanted to, actually, let's save this because this is actually the first lab assignment anyway. So let's save this for after the break. And I'm going to show you the, I'm going to comment this out. I'm going to show you what I wanted to show you, what I said I'd show you before the break, which is this ArcPy, the ability to convert any raster to a Python data type called an array. Now, we've used something called an array before in our GIS, so it's a little bit confusing. But this is a true array. Okay? An array, let's think about an array as just a set of numbers. A set of numbers with, it can just be a big long list of numbers. It can be a set of numbers with rows and columns. In our case, it's always going to be a set of numbers with rows and columns. Okay. So we're gonna look at this for a second and say we're going to say import numpy, N-U-M-P-Y. This is the module that you have to import in order to work with numbers. Okay, it's Python's numerical processing environment. It's called numpy. You import numpy, and what we're going to do is convert our output raster data set to a numpy array, to an array. So some people call it a numpy array. We're going to convert it to a numpy array, and we're going to use this function called raster to numpy array. All right. And we're going to get into this a little bit more next week, but we want to introduce the topic here. It doesn't show up. Just search for it like this. Okay. Oh, no. Oh, there it is right there. I don't know why 10.1 doesn't show up. Hopefully this works on your 10.1 machines. If it doesn't, tell me. All right. So where is raster to numpy array? All right. So arcpy.raster to numpy array, you feed it the raster you want it to work with. We're going to feed it our out RAS. And then that's really the only thing you need to give it. One nice thing is that it provides the ability to do some options, okay? Some options that it allows you to do is to feed it a subset of the array. Okay, you could just give it a lower left corner and it's going to feed a subset of that array in. We're not going to do that. The number of columns and the number of rows to convert, so we can convert just the first 3 or just the first 100 columns or 100 rows. We won't do that either. But one thing that's nice is that you can tell it to convert no data values to a certain value. Okay? Convert no data values to 0. So that's this right here. Okay? So it's going to convert our no data values to 0. And the next thing we're going to do is say print. Oh, we got to assign this to something. We got to say this is our array. Our array is equal to this. And we're going to print our array. Okay? It's going to be a humongous array. So we're going to print it. It's loading it into memory. And it's telling us the values inside of it. Now, we can't actually see the values because it's returning the upper left 9 values, the upper right 9 values, the lower left 9 values, and the lower right 9 values, which all happen to be zeros. Okay? But we could do something like ask for the length. Sorry, the size. Size is the function that we use to get the size of an array. Oops, sorry. I think it's a property of the array. Don't know for sure. Run this and see. It might be what I said the first time. There's a whole NumPy help thing. So if you say NumPy array size, look at it. It was like the first thing that popped in there. It's a question. Okay, it's dot size without. It's not a function. It's just a property. The array dot size. It'll return a tuple of the size of that array. It's going to be really big. Okay. That's the size of the array. That's how many values are in that array. Go back to here. The number of elements in the array. Okay. Another thing that we could do is say shape. Shape will be important for us because our arrays will always have a shape that's not just a bunch of numbers. This is telling us this is the number of rows, this is the number of columns. Okay, that's what that's telling us. Okay, so let's see. We can also do other things that you can do these in Python, but they actually take slightly longer in Python. Sorry, in ArcPy. So let's say I wanted to find the maximum value in an array. I could say NumPy array maximum value max, and there's a function for doing this, the maximum value. So let's go back to that help workout and say that we want to find the maximum value in our array. It's actually, we have to type NumPy dot maximum and then say the array that we want to find the maximum on. Okay. Now we run this and it's going to tell us the maximum temperature or precipitation value in that entire data set. So it may be that you actually want to output that information to the user. Invalid number of arguments. X1. Oh, it's the maximum of two different data sets. So this isn't the one I actually want. I want to get the this is basically saying, okay, if I have two different arrays, find the maximum of the two values and return them in a new array. Okay. So this would be something like, if I want it, let me save this. Sorry, let me go back to array.shape. I'm going to save this because now it's just going to tell me the shape of the array. And now I'm going to save this as example 2. Now in example 2 here, what I'm going to do is not do this. I'm going to do this. And then make this interesting, make this July. Okay, so array 2 is going to be the data from July. Array 1, I'll call this array 1, make it easier. Array 1 is going to be the data from January, or 6 is June, right? So not that it matters, but we got January and July, opposite times of the year. Array 1 is the data from January. Array 2 is the data from July. Okay, so now I could use that function numpy dot maximum and feed it those two arrays, array 1 comma array 2. And I'm going to run this, make sure it works. And what it's going to do is it's going to find the maximum value out of these two values. So if I had a question, you know, I want to find the maximum rainfall, and I knew it was either in one of these two data sets, then my output raster now is going to contain, well, it's not a raster yet. My output data set is going to contain the maximum value of both of those inputs. So I'm going to run this guy to make sure it works. And then we'll do the final thing that we're going to do with this data. Okay, so it works. It's hard to tell that it's working. Why? Well, because we're only seeing the upper left, upper right. What if we want to see the data set? Well, there's the opposite of this. The opposite of this goes the other direction. Okay, so instead of printing it, let's just save it back out to disk. Okay, we can use the function numpy array to raster data set, which is right here. All right, so we go right there. I've got my numpy array to raster data set. I'm going to feed it this out array. And I'm not going to worry about the spatial dimensions right now. We'll do that in a second. So I'll just delete this. It may actually be required, but let's try to run it and see if that's a problem. So I'm going to save this as this data set. Save that like that. And I'm going to call this precip max and run this. Say OK. Let's see if it has a problem with me not setting the cell size. No, it didn't. Okay. So I can go in here, and if I look, refresh, I should have a new data set called precipitation max. Okay. So this data set contains the maximum precipitation of those two input data sets. So we've got our, this one is January, January, and you can see, like, look at how the precipitation changes. There's a lot here in the middle of Central America in January, sorry, not Central America, South America, and there's a lot in northern South America in July. If I look at the max data set, I get both of those because I'm getting the maximum from both of those data sets. Now I could have done that exact same thing using Python, but you'll find that as your operations get more and more complex, that it's actually faster to do the processing in NumPy using this technique. The reason is because NumPy has been optimized to actually run the code right on the computer. It's running code that they wrote in a very basic language called C, whereas the ArcPy code is wrapping those functions in spatial analyst tools, and so there's actually more steps going on in the background. Okay, and there are functions that are pretty much impossible to do in one or the other. So there are cases where one's better than the other, and we can demonstrate those next week. Okay. Drawbacks. Why would you not always use NumPy then? Well, one of the big drawbacks is that it does not, like, once you convert it to an array, you lose all the spatial information. Okay, the arrays have to be the same size before you do the conversion. So sometimes what you'll do is you'll just create a new raster of the same size. You create a new raster that's the size that you want it, then convert it to NumPy array. And you'll have to do, if you have 2 or 3 rasters and they're all in different sizes, you have to convert them all to the same size, convert them to a NumPy array, then process them, then convert them back. All right? Okay, so that's example 2. All right, so we're going to stop there, and we'll take about a 10-minute break, and I'm going to upload my examples and the README for this week so that the lecture notes are actually there. I just have to do that process where I delete some things and clear out my thing. It'll take me about 10 minutes. So we'll meet back here, and then we'll do the lab. And there's something I want to show you, because there's different ways to approach. The first part of the lab is that you want to take a bunch of values and add up a bunch of values in a raster data set. There's different ways to approach that. That has to do with, or in that we'll cover this eval function. Have we used the eval function before? I think we briefly mentioned it at one point. Okay, but we'll cover it again because it's kind of a cool little function, then we'll do that. I'm going to go ahead right now and stop this because I need to take the computer to my office to update it. So I'll stop the broadcast and I'll create a new broadcast for this week.